We have booster ignition and liftoff of Columbia, reaching new heights for women in X-ray astronomy.
The main thing Chandra does is take these superb, sharp images.
Black holes have a bad reputation. After all, something that could swallow you completely sounds pretty scary. They're invisible, so maybe there's one just around the corner and we don't know it. Also, aren't the enormous vacuum cleaners capable of destroying anything that gets near them? Once the black hole starts pulling on something, isn't that just a one-way ticket to oblivion? Well, not all of these things are exactly true. Dr. Paul Green of the Chandra X-ray Center helps us tackle some of these black hole misconceptions.
First off, we can't see inside a black hole, because anything that goes over the edge is gone forever. So that's partly where the name comes from. But it's often true that only a small fraction of the material near a black hole falls in, while most of it just circles forever. The stuff falling close in toward the black hole gets superheated, and we can see that in X-rays with Chandra. Let's use a hypothetical situation to think about the effects near a black hole. Suppose that our sun were replaced overnight by a black hole. The truth is, the Earth wouldn't budge. That's because our orbit is determined only by the mass of the Earth and the sun and the distance between them. As long as the black hole still had the same mass as the sun, we'd stay in the same orbit. This shows that black holes don't always suck everything in. In fact, if they did, wouldn't the entire universe have been digested into one big black hole by now?
Let's listen to Paul Green explain how the scene around a black hole is certainly more complicated than just a simple cosmic vacuum cleaner.
Think about water going into a drain. Water never goes straight down a drain. Instead, it always forms a vortex or whirlpool. And the reason for this is because it always has some spin to it. The same is true of the gas and dust that funnel into a black hole. If the matter can't lose its spin, it will just go into orbit as a disk around the black hole. It's called an accretion disk. Within the accretion disks around black holes, the atoms and molecules jostle each other with increasing ferocity as they rub together in a spiraling mosh pit death dance as they are pulled towards the hole. So, in some ways, these particles are fighting for their cosmic lives, and some of them will win.
If not everything around a black hole is doomed, what happens to that majority of stuff that doesn't fall in? Paul Green explains.
The material falling around the black hole can never reach the black hole itself unless it loses enough angular momentum. One way this happens is through outflows. That's right, black holes don't only suck in material, they also blow it out. Nearly every black hole that is accreting matter is also expelling it. This happens while the matter is still outside the black hole itself, since as we know, nothing can escape once it's within the radius of the hole.
So now we know black holes just don't take stuff in, they send it out into space. And this isn't just for fun. This affects the environment around them, as Paul Green describes.
Black holes form jets and winds of spectacular power and variety. The matter is expelled in many cases at huge velocities, close to the speed of light. Sometimes outflows shut off the black hole's own fuel supply of inflowing matter. But these energetic outflows can also have profound effects on the environment of the black hole. Outflows from supermassive black holes may shut off the growth of galaxies or even stop the inflow of gas towards the centers of galaxy clusters.
So black holes aren't entirely black, and they aren't just the harbingers of destruction that their name might suggest. In other words, maybe they aren't something just to be afraid of, but also to be in awe over. It turns out that black holes are an incredibly important part of our cosmic ecosystem. The more we learn about black holes, the more it seems we should be glad that they're around. For more information, visit our website at chandra.harvard.edu.
This was a production of the Chandra X-ray Center, Cambridge, Massachusetts. NASA's Marshall Space Flight Center manages the Chandra program. The Smithsonian Astrophysical Observatory controls science and flight operations from the Chandra X-ray Center.